Hi, Professor Bob Young here. This is video number 5, College Trigonometry. And in this instructional video, we're going to go ahead and graph some trigonometric functions, beginning with the graph of y equals sine x and its variations, y equals cosine x along with its variations. We're going to do some vertical shifting, horizontal shifting, and so forth of sine and cosine curves, which should match up with your college algebra and pre-calculus algebra graphing techniques that you use. We'll discuss those as well. And we're going to model some periodic behavior at the end of this video. All right, so the general equations for both sine and cosine, and they have their similarities, they look very similar. Y equals A times sine of bx minus c plus d, or that cosine here. What we want to do is identify the amplitude of the functions, and this will help you with the y values of the graphs, and this is very easy to do. You can just look at it and tell. So we're going to say the absolute value of this A number, whatever it is, positive or negative, will be the amplitude. And remember, taking the absolute value will always come out a positive number. The period of the sine or cosine graph is going to be 2 pi divided by b. So remember that whenever you're doing sine or cosine, if we were to take one trip around the unit circle, we would start at 0 radians and go all the way around to 2 pi. So we're always going to graph in radians here because it's easier to do it that way. It says find the phase shift where the graph will start on the x-axis, and this is what's called, it's the first endpoint. And to get the phase shift here, you're going to say that is minus c over b. Now, if you remember your college algebra or pre-calculus algebra, if this was a minus number here, it usually shifted the graph to the right. If that was positive, it shifted left. And in pre-calculus and college algebra, a lot of times you didn't have this b number to deal with. But in trig, you will, so don't worry about that. We'll go through some of these and you'll see it as we go along. In step 4, we're going to find the values of x for what's called the 5 key points. And we're going to start with the value of x where the cycle begins the phase shift here, and we're going to add quarter periods or period divided by 4 increments to whatever we start at on this phase shift here. And that's going to allow us to find the successive values of x. And when we do the 5 points, the last point is going to be that last or remaining endpoint of one full curve, as we'll see. All right, we're going to connect the 5 key points with a smooth curve and graph, one complete cycle, and we're going to extend the graph left or right if necessary. All right, so we're going to begin graphing the basic y equals sine x graph, and we're going to look at this form we talked about earlier here. Now, the amplitude is the number in front of the sine of x here. Now, but Young, there is no number. Oh, yes, there is. It's the absolute value of 1, which the amplitude on the sine graph will be 1. The period 2 pi over b. Now the b number is in front of x here if you look at this form. And again, b is going to be 1. So the period will be 2 pi over 1, which will give us a period of 2 pi. The phase shift now, there is no c number here. So that would be 0 if we were to go ahead and put x plus or minus 0 in there. So we're going to say there is no phase shift here. We'll just say that 0 over 1 or 0. So that's where the graph is going to begin. So this phase shift tells me where I'm going to begin here. Okay, and we're going to get the nice x values by taking the period, which we said was 2 pi, and dividing that by 4, which will reduce to pi over 2 increments. So we're going to start at 0, and we're going to keep adding pi over 2 to get those 5 key values here. So 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 would be 2 pi over 2, or pi. Another pi over 2, if keep adding, would be 3 pi over 2. So I'll just make a note over here. We're just adding pi over 2 all the way down here. And then we'll be back to to pi. So we have our 1, 2, 3, 4, 5 key values, and that's going to be very important when you're graphing these. Now, also knowing your unit circle will help here. If you take the sign of 0 here, if you put 0 in for x, the sign of 0 is 0. And these are going to be your quadrant angles as well, by the way. The sign of pi over 2, when you plug that in for x, y will be 1. The sign of pi back to 0, 3 pi over 2 would be -1, the sign of 3 pi over 2, and 2 pi back to 0. So I'm going to go ahead and plot these points, and I think I'll take red and use a pretty color for it here. All right, so 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. And go ahead and connect your points now and make a nice smooth curve here if you can. Now I have to be careful on my writing tablet because it can slide on me and so forth and so on. All right, so from 0 to 2 pi, this would be considered one full period on your graph. Now, some important points to look at here. We're going to say that this point here on the sine graph is called a maximum value. Okay, this point down here is going to be a minimum value. And the points where the graph crosses x here, these are called intercepts. All right, and I'm going to teach you a way to cheat on these and recognize these. If you go intercept, maximum, intercept, minimum, intercept, once you get one full wave or you even start getting a wave, you can start kind of cheating and go from there, and you can keep doing these as much as you want. Like if you wanted another period here, if this was the maximum intercept and you knew your intervals here, you could go ahead and say, well, this would have to be minimum intercept, maximum I mean, it keeps going forever and ever like this. So the graph would just keep going. And you know what I tell my classes here? I kind of get funny and I do my opera singer thing. I go me, 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 or I can go imini or whatever. But what it means is intercept, maximum, intercept, minimum, intercept. And it just keeps doing that forever and ever. And we're going to look at some other things about the sine function as well here. All right, so looking at this sine graph we did, what I went ahead and did is pulled up some more points here. So we took the points 0, pi over 6, pi over 3, pi over 2, and we went all the way around using just about all the unit circle points to 2 pi, and we got our y values here, which you know will come out 1/2 0, square root of 3 over 2, and they'll change as you go around the quadrants and so forth. All right, so if you look at this, as x increases from 0 to pi over 2 up top here, notice y increases from 0 to 1. And then as x increases from pi over 2 to pi, y decreases from 1 to 0. So remember in college algebra and pre-calculus, increasing, decreasing, and so forth, and then it will increase again as we will go, it says x increases from pi to 3 pi over 2, y decreases from 0 to -1. So really it's decreasing all the way down this interval right here until it hits 3 pi over 2 to 2 pi, and then it begins increasing again. Also, look at the period here. We started at 0 and we did one full period here to 2 pi. And then I said, remember, you can do your mimi and do as many periods as you want. So once you know you have intercept, maximum, intercept, minimum, intercept, maximum, intercept, you can do the me forever. Forgive my I need to keep my day job here. Notice the range is y values are always between -1 and 1 on the sine graph as well here. The domain is going to be -infinity to infinity, and we can go through some cool things here. Range -1 to 1. Now it can equal -1 to 1 in interval notation, so be aware of that. Period is 2 pi. We said that earlier in the graph. And notice the function is an odd function here, because if you take and replace x with negative x here, you get the opposite of what you started out with. If you remember your college algebra, pre-calculus algebra lessons, and I always taught my class that an odd function had origin symmetry. So notice this thing goes about the origin as it continues onward. Next up to bat, we're just going to go ahead and graph the general function y equals cosine x with the same strategy as we did with sine here. The amplitude again would be the absolute value of 1 or 1. The b number on cosine is also 1 here, so we would get a period of 2 pi. There is no c number in this one. I know y'all are hurt and say, I want some with c and d numbers, Young. Don't worry, we'll get to them. We don't do just the easy ones in this video series. So we're going to say the phase shift is, again, there is no phase shift. It's 0 here. All right. So the nice x values, very similar to sine here, is going to be the period 2 pi divided by 4 increments, or pi over 2 increments. So again, we're going to get our 5 key points. We're going to begin when x is 0. We're going to go pi over 2 pi, 3 pi over 2 to 2 pi. Now, the cosine's a little different creature here, because be careful on your circle here. The cosine of 0 radians gives us y as 1. And if you don't believe me, put your calculator in radian mode and do that. The cosine of pi over 2 would be 0, pi, negative 1, 3 pi over 2, 0, and 2 pi would be back to 1. So we're going to go ahead and graph this in red like I did the last example here. All right, so the point 0, 1. Now remember, the sine went through the origin. The cosine begins up here on 0, 1. So there's a little bit of discrepancy already. Pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. Back to 2 pi. And you can go ahead and connect your dots here. Make a nice rounded, smooth curve. And again, on my writing tablet, that's always a challenge. And there is one full period of your cosine graph. Now, Young, can your me keep going if I want to do more than one period? Absolutely. Watch this. Intercept, maximum, intercept, minimum, intercept, maximum. You can do this forever and ever and ever. Try to keep those curves as smooth as possible. Sometimes I have people with pointy curves in here, and that drives me crazy because these are supposed to be smooth. All right, so there is your graph of cosine, and we'll look at some more interesting things about it as we progress. All right, on the cosine graphs, notice as x increases from 0 to pi over 2, that y decreases from 1 to 0. So as x is increasing here, y is coming down. From x increasing from pi over 2 to pi, y also decreases from 0 to negative 1. So again, this is decreasing along this path. And then when it hits pi to 3 pi over 2, it begins increasing again. And there's my dog Lucky in the background barking. Never know what you get on these videos. And it continues to increase as x increases from 3 pi over 2 to 2 pi. So x is increasing along here, notice, from left to right, and y is behaving differently. All right, now some properties of y equals cosine x here, and we talked about this with sine as well. The domain, negative infinity to infinity. Range, negative 1 to 1. Period is 2 pi. And the function's an even function. The cosine, when you replace x with negative x, cosine minus x equals cosine x. If you remember those negative angle identities we talked about. And I always tell my pre-calculus and algebra students an even function has y-axis symmetry. Now Lucky is trying to get in my lap here. So notice this, he's not happy with me doing the video, has y-axis symmetry here. All right, now one interesting note to compare sine and cosine graphs, the graphs of sine Functions and cosine functions are called sinusoidal graphs. I don't know if they have allergies or so forth. No, stop it, Young. And the graph of y equals cosine x is the graph of y equals sine x with a phase shift of pi over 2. So notice, in other words, if I were to take this graph and shift it pi over 2 to the right, it would be this graph. Or if I took this one and shifted it pi over 2 to the left, it would be this graph. And I wonder if this has something to do with those cofunction identities we talked about in earlier lessons in that first quadrant. Oh yes, they definitely do have something in common there. So the cosine of x equals the sine of x plus pi over 2. Now, one other thing about these sinusoidal graphs in this form, we haven't talked about the D number yet, so I want to go ahead and talk about the D number. It's going to either shift the graph vertically up or down. Now, if you remember your functions from college algebra / pre-calculus algebra, whenever you added a number to the end of any function, it could have been a line, parabola, a cubic function, a square root function. It either, this number at the end shifted it up or down, and it's going to do that as well. And it's going to affect the minimum and maximum values we've already talked about. So we'll go ahead and look at one of these graphs now. We're going to go ahead and determine the graph of y equals 3 sine x plus 2. Now what I might do on this one is go ahead and graph just the y equals 3 sine x and then go ahead and put the 2 in there as well and show you what happens. So let's go ahead and look at that. All right, so we'll go ahead and identify some things here. We'll make some points over here and we'll go from there. All right, so the amplitude on this one would be 3. So I'll go ahead and we'll put the absolute value of 3 as 3 in here. So I'm just going to go ahead and graph this y equals 3 sine x graph to show you what happens with this amplitude number first. The period, the b number, is still going to be, if you look at the b number here, it's still going to be 1. So we're going to get 2 pi over 1 or 2 pi. There is no c number. We'll get to those. I know y'all are, come on, Young, give me one that's got everything. Stop it. All right, so the phase shift would be 0 here. And the nice increments of x, the period divided by 4 would be 2 pi divided by 4, so you'll get pi over 2 increments. So I'll go ahead and put 0, and we'll keep adding that pi over 2 here, as we have done. And we will get our nice quadrant angles here. So if we put 0 in for x here, 3 times the sine of 0, we're going to get 0. Now, I'm not messing with the 2 yet. I'll show you what happens with that in a second. Y'all ooh and ah go, ooh, wow. Sine of pi over 2 is 1. So if you want to, you could come over here and put 3 times the sine of pi over 2. You could go to radians, put that in your calculator, but I'm hoping we start learning that unit circle, especially these quadrant angles, better, so we don't have to waste the time doing that. The sine of pi would be back to 0. 3 pi over 2 would be -1, so we get -3. And then at 2 pi would be back to 0 here. So I'm going to go ahead and do this one in black. If this were just y equals 3 sine x, we'll start at 0, 0. The sine typically does that. Pi over 2, 3. Pi, 0. 3 pi over 2, -3, back to 2 pi, 0. So we'll go ahead and connect the dots here, and I'll try to make this curve on my slick writing tablet the smoothest and prettiest I can there for one full period. All right, so that's what this graph would look like. Now let's add 2 to it. So if you were going to add 2, all of these would shift 2 units up, all of these 5 key points here. So I'll do that in red and we'll look at it. All right, so the 0, 0 shifted up 2 would be 0, 2. The pi over 2, 3, we'll just take each one of these 5 key points and we will just shift them up 2. And some college algebra and pre-calculus algebra teachers will teach it in this manner as well. I think I've got all of them 2 up. And you will see how the shifted graph, so here's what D does to it. And I always tell my trig students, if there's ever that D number in there, just graph the function first and then just do what I did and just move those key points up or down, depending if that's a plus or minus. That just shifted this one 2 units up. So that's how that one works. And we're going to look at some more examples with lots of other numbers and so forth in here to make sure that you have it. All right, in our next example here, we're going to look at the function y equals 2 sine 1/2 x. And again, we're in this form here. So the amplitude on this one is going to be 2. The period, 2 pi over the b number. Oh, Young, the b number is a half here. So you threw a fraction at us? Oh, no. So 2 pi divided by a half, multiplying by the reciprocal, will be 4 pi. The phase shift on this one, now again, there is no c number. Don't worry, we'll get to some of those. It would be 0 over a half would be 0. And then the phase shift would be the period of 4 pi divided by 4, so we would get pi increments here. So on this one, if we start at 0 and we keep adding pi, we'll get 1 pi, 2 pi, this is an easy one here, 3 pi, 4 pi, and we'll go ahead and adjust our x-axis here, 1 pi, 2 pi, and you can do this, 3 pi, 4 pi, and we'll go both directions here, negative 1 pi, negative 2 pi, negative 3 pi, and so forth. All right, so if you plug 0 in for x here, 1/2 times 0, 0, you'll get 2 times the sine of 0 is 0. If you put pi in here, you're going to get 2 times the sine of pi over 2 is 1, and then you'll get the sine of pi over 2 is 1 times 2 is 2. If you put 2 pi in here, half of 2 pi is pi. And what's going to happen, and you can start seeing how to cheat here. I hate to show you this too early on, but if we go to graph this, let me get my red out. Starting at 0, 0, and going pi 2, 2 pi 0. I guess I missed my red. It stayed black on me there. So if you go intercept, maximum intercept, I bet you know what this next one's going to be. Minimum intercept, me. You can begin cheating on these, and then here is your graph of y equals 2 sine 1/2 x. All right, we've been doing sines. Let's do some more cosines here, and I'll throw in some other creatures here. I'll throw in, let's graph y equals -4 cosine pi x here. So we'll go through our strategies. We'll get a little quicker graph in these, show you how things work. The amplitude here would be the absolute value of -4. So you would say 4 if asked that on a test or so forth. The b number here is, oh, it's pi, Young. What are we going to do here? We're going to get 2 pi divided by the b number being pi. That's a number in front of x now. The pi's will cancel out, leaving you with a period of 2, a regular number. What? There is no c number here yet. We'll get to those. We got a few coming up in our next examples. You can fast forward if you want to see a c one. Would be starting at 0 here. And the phase shift would be this period here of 2 over 4. So you would get increments along the nice x values of 1/2. All right, so let's go ahead and we'll put that in here. So we're going to put in 0 to start our phase shift. And we're just going to keep adding 1/2 to this. 0 plus a half plus a half, 1 plus a half, 1.5 for 3 halves, another half. 1, 2, 3, 4. I do believe that's all 5 of them right there. Okay, so when we put in 0 here, we're going to get -4 times the cosine of 0 times pi is 0. And the cosine of 0 is what number? Do you know your quadrant angles? Do you know your circle yet? Is 1 times -4. We would be at -4. Now remember in college algebra / pre-calculus algebra, when you negate a function, it reflects it about the x-axis. Now normally the cosine would start up here somewhere and then start doing this kind of thing, but that negative is going to change things. It's going to start down here. It's going to flip about x. So these behave like functions in all of your other courses as well. Notice if you put 1/2 in here, you'll get -4 times the cosine of 1/2 times pi is going to give us pi over 2. The cosine of pi over 2 is what number? 0. We're at 0 here. Now let me show you something I haven't shown you yet. I don't know if you want to do this, But here's what I'm thinking. I'm thinking this is going to be a minimum value. This is going to be an intercept. I would almost bet when I put pi in here that I'm going to get a maximum value of 4, and will I? Or, I'm sorry, not pi here. I forgot to change my axis, silly young. If this is 0, this is 1/2. This is 1. This is 3/2. Forget about the pi. Let's just scratch out the pi's here. That's what we'll do. Put a 1 in here. Negative 1. Let's scratch out the pi's on these. So that's our x-axis. 1/2, 1, 1.5, 3/2, 2. Sorry about that. All right, and then I'm going to bet if I put 1 in here, I'm going to get negative 4 times the cosine of pi times 1 is pi. The cosine of pi is negative 1 at 4. So watch me start cheating here. I can go minimum, intercept, maximum. I know that must be an intercept. Minimum. You can keep doing that and go me. I know some of you are hurt on this graph because I didn't use color, so this one really spikes out there. And there it looks. And we could keep doing this. Minimum, intercept, maximum, intercept, minimum. We can keep doing that for -0.5, -1, -1.5. And again, try to make these nice and smooth. Sometimes it's hard on this writing tablet. The higher up I go, I really get in trouble sometimes. I even do that in my regular lecture classes. So there's what that graph would look like. So again, notice the amplitude is still 4 up and 4 down here. So I guess that's why they always take the absolute value to kind of give you the height and so forth on here. Now, would you have panicked if they would have put a minus 1 in here or something on the end of that? You would just take all of these points and shift them down 1 if you were to do that. So, you know, that D number would just move it up or down. And for our last example here, we're going to throw the kitchen sink at you. We're going to take the graph of y equals 3 cosine of 2x minus pi over 3 here. So this has got the A, B, and C numbers. And remember the D number, you could just graph this one and move it up or down. So the amplitude on this one is going to be 3, the absolute value of 3. The period will be 2 pi over B. Now notice the B number here is 2. So the period will be pi. The phase shift will be minus C over B. So C is going to be I'm going to call this, now you would think about this in college algebra with a minus in here. This would shift to the right. I think y'all would see it. When that's a plus, it shifts to the left. So this sign here, I wouldn't worry too much about, but I'm going to say that's going to be the pi over 3, and then that's the C number over the B number would be 2. So it would be pi over 6, a pi over 6 shift to the right. So that's where I would begin my shift here. So again, if that's minus right plus left. All right, and then the period of pi over 4 here, period divided by 4, would be pi, is the period, over 4. So you would have to keep adding, and here's how this works with everything here. Keep adding pi over 4 to get your 5x values to pi over 6. All right, so I'm going to come over here and say pi over 6 plus pi over 4 would be 5 pi over 12. And I've already went ahead and worked this out, getting common denominators and so forth. And then 5 pi over 12 plus pi over 4 would give us next 2 pi over 3. That would reduce. And then 2 pi over 3. So if I keep adding pi over 4 to this, my next one will be 11 pi over 12. And I'm just hustling this along to try to keep this video somewhat short. Too late, young, I know. And then the last one would be 7 pi over 6. So adding to this initial one, here's what we've got so far here. All right, now at pi over 6, if you put that in here, you're going to get 2 times pi over 6 is going to be, and I'll sneak this one in down here. So I tried to leave room to do a lot of stuff. Pi over 3. So you're going to have pi over 3 minus pi over 3 is going to give you the cosine of 0 times 3 is going to give us 3. All right, so if I'm thinking cosine here and I'm going to go ahead and shift these x values here at pi over 2, I'm going to call this pi over 6, 5 pi over 12, 2 pi over 3, and this next one would be 11 pi over 12, and then I might even go out one more here to get the 7 pi over 6 since this shifted to the right on this one. All right, now watch what happens if you go pi over 6, 3. Now remember, cosine, if there's not a negative here, I would expect it to start off of this. And then you could do some cheating and say at 5 pi over 12, and you can plug this in and check it, maximum, intercept, minimum, intercept, maximum. When you do enough of these, you'll be able to be this good, ladies and gentlemen. And there is your graph of one period. And you could go ahead and keep doing this endlessly in both directions. And this is one of the toughest ones there are here. So that is how you could do it. I don't know if I should have taught you that cheating method, the old me. But as you do more of these, you'll want to know how to do them even faster. All right, the last example we're going to look at is modeling this periodic behavior. So we've got a region that is 30 degrees north of the equator, averages a minimum of 10 hours of daylight in December. Hours of daylight are at a maximum of 14 hours in June. Let X represent the month of the year with 1 for January, 2 for February, 3 for March, and so forth until you get to, of course, December 12. If Y represents the number of hours of daylight in month X, use the sine function in this form we've been describing and talking about throughout the video to model the hours of daylight. Because the hours of daylight range from a minimum of 10 to a maximum of 14 here, the curve oscillates about the middle value, 12 hours, so we're going to call D 12 here. So we'll see if we can make this make sense in a real world problem here. All right, now there's the problem again. Now it says the maximum number of hours of daylight is 14, which is 2 hours more than 12 hours. Thus, I would call the amplitude in this one 2. So we're going to say A is 2. One complete cycle occurs over a period of 12 months. So we're going to say the period would be 12 equals 2 pi over b. That will give us this b number. So multiplying both sides by b to eliminate the fraction, 12b equals 2 pi. Divide both sides by 12 and b will be pi over 6. So the starting point of the cycle in March, x equals 3 here. All right, so we'll go ahead and say the phase shift then in March will be 3 equals c over b. And we will get the c number by substituting in pi over 6 for the period we just found. Multiplying both sides by the LCD, 3 times pi over 6 will get us pi over 2. So there's your phase shift. So looking at all this put together, we can say with the A, B, C, and D numbers that this equation models the hours of daylight. Y equals 2 sine pi over 6x minus pi over 2 plus 12. And if you want to graph this one just for fun, do so and see if it makes sense when you look back at it. All right, this concludes video number 5, graphing sine and cosine functions.